Yeah, so my name is Robert Engels. I work at NRK in the Origo program. Guy Burdan, who is here, he is the main project leader and project owner for this project in NRK. So I just do technical stuff and find out whether things work or how we should make them to work. One of the ideas is that we have a multimedia archive at NRK with television, with radio, with sound, with music, everything mixed in broadcasts, and we want to find out more about it. So what we did the last 3 years is making a good archive solution. So that's what happened on my side since we met last. So we made a good archive solution. So we have the whole radio production of NRK in a new infrastructure, new machines, new software, new production flow. And that means that everything is going automatically from production to an app on your telephone after broadcast. It's going on antennas, it's going in the apps, it's going in the archives. Metadata is automatically retrieved from production systems, put in the archive. We share it with National Library now. We're working together with Richard James on the Volkenmuziek solution. So this is quite an exciting time. And we did do this infrastructure. It's been running for the last 1.5 years. And we still have radio on air, so it works. So that's good. So what else can we do with it? And that's the reason why I'm here. Because I got education from several universities in Sweden, in Norway, in Amsterdam, and in Germany. And I have a PhD in machine learning. So I like very much to use it, finally. The last 2-3 years, I finally was allowed to use my education. And that's what we're trying to do now. So the funny thing is that we have a lot of sound, but we miss a lot of metadata. So we lack metadata for the sounds that we have. Think about recordings from 1945 or 44 with Quisling during the Second World War, the 1972 U-boat crisis in Songdal, whatever, 1980s, the wall that tumbled, things that happened in Norway with, in July in 2011. I mean, we have a lot of material, we have a lot of sound files, but we lack metadata to find it back. So in this program, we put up some, in this program, we put up some tasks. One is the analysis of historical material, music, and the other one is the analysis of spoken words. We want to make transcriptions so that journalists at NRK and other researchers from the universities can easily find back to statements by people, often politicians. So we started with that kind of stuff. What can we do with the text and with the spoken words, and what can we do with the music? The old recordings from radio from the 50s, 60s, there's a lot of music, there's a lot of speech, and we don't really separate between them. So that's the first task that we wanted to do. What we were not aiming at doing is clustering, self-organization, latent structure in the documents. We don't try to actually put radio programs together yet. I mean, we can do that, but that's not the case here. That's not what we wanted to do. What we also didn't want to do is find out some high-level general content analysis. Is this a disaster, an accident? Is this music? Is this folk music? Is this politics? What is it? Not interesting. What we also didn't do is data cleansing yet. I mean, we will do that later. This is the famous Christopher Scow. Only his name you can actually write in many different ways. And believe me, we have them in our archives, every single possibility. So, I mean, it gets worse if you go to classical music with Tchaikovsky and so on. Just imagine if you have archivists back to the 60s in the last millennium, and you have all these generations of archivists that use different Latin spellings for Tchaikovsky, then you get a lot of variants. These kind of problems we don't really see as interesting because they're mainly solved with today's technology, so we didn't look at that. Data health is also not really what we were looking into. Here there are some duplications and there is some data there that we can't really read, but that's not the issue here. Too. We had some other issues that we wanted to work with. So one thing that we did was actually, for those who speak Norwegian, they know that in Norway there is 3 official languages. So we had Bokmål and Nynorsk, but we also have Samish. So we let out Samish, but we made actually an open source tool that is on GitHub. We make a lot of open source software in this program at NRK. So you can find it there, you can use it. This is for using in search engines. If you have journalists on the West Coast that search with Nynorsk and they want to have results in bookmall, because nearly all metadata in NRK is in bookmall, then this tool will help. And this is integratable with Elasticsearch. You can just plug it in. So if you want to use that, it's quite funny. And you can help us making it better. So this is one of the things that we then contributed. Our audio, there's a lot of frustrations with audio. First, this is the oldest thing in NRK. I mean, they started in 1933 with radio. There has also been the longest tradition of trying different things. So there is a very hybrid environment there. Audio is not as accessible as video. I must say from my experience, the image recognition stuff is nearly solved. I mean, these algorithms are better than we can. But for sound, it's not solved at all, like we saw today. So audio feature extraction is interesting. Audio technology stack we have to look at. Music segmentation we need to work with. We want, of course, to do music fingerprinting. And for commercial stuff, this might be working. But if we are talking with Tono and Phono and Gramo, they want to know which label actually put this music out. So if you have a classic recording, it's great enough that you can find back the classic recording, but which exact recording it is, that is difficult. So that's the kind of stuff that we have to look into. The speaker ID, speaker diarization, and speech to text, so that we can search in transcription. So that's where we actually wanted to use some energy, and that's what we did. So we started with the speaker ID. The speaker recognition is great. I mean, you can, within a radio program, it's quite easy to find a speaker, to find out which speaker is where. So this is man 1, this is man 2, then it's man 1 answering, then there is a woman. That's okay. Putting it to a speaker ID, setting a name on it, is more difficult. That's biometric. Erna Solberg for 10 years ago and Erna Solberg now is not actually the same voice, or Jens Stoltenberg in 1980s and now as a NATO Secretary General is probably not so easy to find out. So this biometric thing with speaker ID over time is something we have to look into. The speaker recognition in our database should be a closed world problem. It's not always like that. So we tried one thing, Dagsnytt 18, that's a very nice program with recordings, voice recordings from like 27 years. Was that correct? Yeah. And we had like nearly 1,600 different people in 2016. We had 2,700 guests, but 1,600 unique guests or people. So that's quite interesting, because then you can do speaker recognition. That's what we did. So we have this archive. We took the sound file and we tried to put speakers on it. That works for some of them, the ones that we learn. But if you run it on the whole Dagsnytt 18, 5 out of 6 speakers might be unknown to the system. So that was one problem. We also had another problem because then we said, okay, we can also start with transcribing, also speech to text. That didn't really work either. And that is because, of course, the sound quality is difficult. It's very different from time to time, and we have material back to 1919. So, and I can promise you, do you know which text this is? Can you actually find out, those who can read Norwegian, what it's talking about? I mean, this is just a transcription, straight from our radio archive. I mean, this is Roald Amundsen's Minnetale om Fridtjof Nansen. And it's talking about Express Liverpool e-cigarettes. I mean, this is from 1928. So, I mean, that is a real problem if you use this kind of tools. So we thought if we can trigger this much more to the people that actually are talking, if we know this is Erna Solberg and we have like all her voices over time, then it's much easier to tune these algorithms into them. So that was one of the things we want to do. We want to do it fully automated. Because we also tried other things. We tried Google, we tried Microsoft, and both of them come with, this is also Dagsnytt Bulletin, this is just news broadcasts. The same fragment interpreted by both companies is still represented very different. But you can, if you as a human read it, you get some feeling for what it's about. So we just did in simple tricks, we put them together, and this is the consensus that they had. And this is what we threw in a search index. So now for this stuff, we are pretty sure that it was in the text files. So here we can already put some pinpointers back, this indexing that you were talking about, this document indexing. We can now make a document index with time points because we know which words are where on the timeline, and we know that these words are pretty sure that we found. So we put them on a timeline. This is, in the top you see the search for sound, Erik Jensen, and then you get like a hit. It's not really sharp on the projector, I'm sorry. But you see here the result from the transcription with the highlight of that part. So this is quite easy. We can also visualize it in the sound file. All this is screenshots from our radio archive. So here you can also identify the segment that the journalist then might be interested in. And from this point of view, a journalist can just share this part directly to the production system. So make a new program with it. So this is like a few seconds to get from the archive to a new production in the radio. And that's what they want. They want to sit in Dagsnytt and just get a fragment. But you said this for like 10 years ago. How do you react to it now? You know, like this kind of nasty questions that you don't want to have as a politician. So we put this in an infrastructure which is virtualized as Docker container, so it's easy to roll out, it's easy to reuse. We can use parts on this in the cloud, so it's very scalable. We got much material, so this is really, really interesting. And where we saw in the previous talks that it was R&D, you know, like what can we do with sound, what can we do with music, how can we analyze it top down, what can we analyze it and get some products out of it. This is really top down. We have a lot of material, but it doesn't really, it is not really usable. How can we lift it up to this level that we can work together? So this is where we start to come together, because we took our material and then we thought, okay, how can we actually identify these voices? In Dagsnytt we have video streams. So we said, okay, we don't want to do anything manual, so let's use the faces in Dagsnytt automatically to identify which people are speaking where, and in the meanwhile also building up an authority register on persons. So this is also the Google API with some screenshots from Dagsnytt. And you see on the left-hand side that it's quite good and easy we have high quality in recognizing faces. There is some extra stuff that you get back from these APIs, like how happy the person is or other things, or how sad. That doesn't really work yet, but it will work in a few years. And we also can analyze logi and texts. So what we now can do is do on-screen graphics detection. We can actually find out graphical elements, and you see that the journalists, they use semantics for actually putting in these boxes. So these boxes have a meaning, and this meaning is automatically extracted by deep neural networks that we implemented that find the graphics, know which role they play, and know which part of the graphics means what. So the name is always in the bigger box in the top. In the lower part you have a role and you have an institute or a political party that the person belongs to. And the little symbol to the left shows if it is a person on the telephone, because sometimes you have persons on the telephone and they show a face and they don't belong together. So these deep learning algorithms actually manage to separate all these cases quite clearly. So that's quite cool. And then we want to actually be able to put all these names that we have in our metadata to these faces and to the sound parts. So we use the clues that we can get. We extract the faces, like you see in the right picture, so that we have these pictures if we make new applications on the net, nrkradio.no or radio.nrk.no or television.nrk.no. We can use these images there to show which people you searched for. We can extract these telephone things, and we did a lot of tricks to make this work. So we actually generated training data, and this is also what you should probably consider. You were already working with that. I saw that you generate your own music by using this MIDI. So you make your own music with some noise so that you can train up these algorithms better and that they get more robust against noise. And this is the way we did it with images, but it's quite similar to what you do with music analysis. So this is quite interesting because here we got quite good results. This man is like Helge Running as a professor of the University in Oslo. So there we know that that's his face, it's his name, we know his role, we know his institution, we know which time of day, and we know on which day it was. So we can actually put that in a database and see what Helge Running looked like over time and which roles he had in society over time based on these broadcasts here. At the same time, we extract faces so that we have a variance. We have different expressions of these persons. We make a database over these faces, so we have a lot of different faces. And some people, like Paul Sheffy, he's very expressive. We have many different images of him. All of this is Paul Sheffy, very different looking in some of these pictures, but more than 98% correct recognition in files. And then we are doing that, now it's getting interesting for this today. Then we can put it on a timeline. So here we now can actually extract voices with the right faces. We know which people are talking, we know where they are talking, we can extract it, and we can put it back in the video, for example, so that we can extract we can put the names in the video later on. Where is that? Here, I think? Yeah. So here you see that the names are coming back with probabilities that we have the correct name. So now we're getting somewhere. So now we're putting things together. We use these deep neural network, Linnet-style convolutional neural networks. We use partial screen scans for this, but this is something, and that's quite an interesting thought, that you also, we have discussed this, how we can use it on music. You talked about these n-grams, or you did, Olivier, these n-grams. I mean, you can use these n-gram windows, just like we do the windows in the images, to use these deep neural networks for trying to find out which kind of music we're playing, and maybe do an automatic genre detection on Rhinelanders and polkas and all that kind of stuff. That should be possible with this technology. So that is then the next thing that we want to do, music segmentation. So that is what we started with now. We have this sound file, and we don't really have the metadata to put it on a timeline. So we have a sound file, 1 hour recording, and we don't really know where the people are talking, where the music is starting, which music is starting. And that is where our work is coming together. Because what we do there is we produce data production, we visualize the data, and that is already quite good, this visualization. We model, we evaluate, and then we put it in production. We want to actually put this in production and do this for the whole archive, the whole radio archive. And that's 1 million. Sound recordings. So we trained on 100 shows from Ukeslut, Spilleroom and Dagsnytt 18. We evaluated on 25 shows from the same programs from 2017, so the year after. And we had 5-second context. So that was that. And we pre-processed our archive. So we had HD5 archives, we pre-processed them so that we got a bit more handy format, but we still have a very large feature set in the data. And if you see what we did with that, the local classification model, we used again this convolutional neural networks for recognizing music and speech, and the quality was really, really, really high. And it's not always so very easy because many radio programs have jingles and music going in and talks, and so that there is actually quite some noise. But we felt that the blue is music and the green is spoken words. But we actually really felt that when we checked it, it works very, very well. So I won't go through this evaluation, but we did a lot there as well. So what is the next thing that we can imagine to work with, which is fun? That is the folk music archive that we're building now together with National Library. So Richard Jems and Hans Hinrich are in this project. These are some screenshots. These are some screenshots of this archive. where we use different pictures. Hans-Henrik had a very good comment yesterday. You can see that this is folk music because there are mountains in the picture. which as a Dutch guy, I must say, we don't have folk music in the Netherlands, according to that theory. And not in Eastern Friesland either. So, no. So we agree on that, Hans. So this is the archive. If you search, you get the general page with artists, with recordings, and with the tracks that this search is related to. Of course, already from this point, you can listen to the recordings. You can go into more details. Dit is de landskaplijken in Jailo, in Super D, with all the tracks and the people related to it. And here you see all the people coming up with roles and all that stuff. And that is something that we have in this authority register. So that means that we want to get the names together with the images automatically extracted from the stuff that I just shown. So we fill up metadata here with machine learning. We try to make these data sets as complete as possible. And here, the metadata here is represented as a graph. So we use semantic web technology. We use RDF graphs, resource description framework. The semantic web technology is a W3C, World Wide Web Consortium standard, just like HTML and XML. And it is very good for actually representing distributed data sets on the web. It's very easy to merge data sets. So if you got a data set at the university, we got one at NRK, and you got one at the National Library, it's quite easily merged. And that's what we do, for example, with Wikipedia, which is also available in this format. So we try to use this metadata, which also means that it would be very easy, for example, for an R&D project at the university to enhance this data set with their own graph data, which relates to this data set. And that's what we, of course, want. I mean, if you come with your stuff that you've shown before, and you do an analysis like you did on this folk music, and you can represent this in this RDF graph data, then with timeline points, then we can just put it in here and we can make our own visualizations together, which would be extremely funny. So I feel that from the bottom up, we have prepared as much as we can. And now we're testing machine learning stuff. You're doing it from the top down, and we should be coming together here. And that would be really good to test out. So that should be the next thing we should do. Let me see if there's more. Yeah, we got all this data from the old data sets that National Library and NRK has. So we're merging our data sets. So this is SIFT. That's a database system, or not even database. It's a metadata system from the late 70s that we're still trying to get rid of. Søk i tekst, norsk data, 1978. And I think NRK started to use it in 1981, and it's still running. So we're trying to get rid of it now. It's a good system though, but it's not relational. So it has some problems with the metadata in today's internet world. So this is an example from the old database represented in the new look and the new folk music archive. So the idea is that all folk music will be here and not all too long. And we have noticed that there's very many people in the folk music branch here in Norway that are very happy that we're doing this job. So we take that as a good sign, and we hope that this solution will be very good to take care of all this metadata. So I think I leave it there. I can, yeah, if you wish, I can show you the radio archive, but I don't know whether that's possible here. Well, necessary. Yeah. Okay, are there any questions?
Yeah, well, first we can thank you for the presentation. I really think this is exciting, so and we do have time for some questions. I could start right away myself. Yeah. I'm really curious because I really see the potential of working together here, but to what extent would, for example, we at the university be able to do some kind of feature extraction on the audio material itself? Because I guess you're talking a lot about things that are represented as metadata really, but like the tools that we are working with and that Olivier has also presented earlier today, we need access to kind of to go through the audio files themselves.
Yeah. Now, yeah, so in principle, we cannot give away all the material we have, but it would be really possible to put together a set of data that we can use in such a project. I mean, for the radio part, there's a lot of material that's already out on the web. 16,000 programs, I think, are already on radio.nrk.no.
220,000 programs.
Yeah, but that's with movie and with television.
That's only radio.
Okay, okay, much more than I thought. 230? Yeah.
Altogether it's 345,000 programs with the television, and it's 220,000
Okay,
radio.
yeah. So there is already a lot, and there is also folk music and that kind of stuff. So, and we will, this folk music archive, I just have to show it, I think. This is the radio archive, this is internally in NRK, and this is radio.nrk.no. So this is the web page that everybody can reach. So here you got, like, for example, where is the folk music there? Folk music. So this is the folk music channel. Live radio, but this is also the archive. And but this is the public archive, so this is what everybody can access. This is what we have internally, and there is like what I said, like nearly 1 million things. This is everything of everything. So here is folk music, here is radio theater from the 50s. Here, I think you can search for Charles de Gaulle here and find some information, some speeches from him from just after the Second World War. I mean, here there is a lot of material. But folk music is also here. So we have a lot of folk music. I can't really read it from here, but I'll just press somewhere, see what happens. Christmas songs. It's probably not what we want. Is this time or is this time? No, this is the, yeah, Östlandsändningen. Okay, so here we got Östlandsändningen, and there you see that we have all the metadata, we have everything from the playlist, we have all the music pieces here, and you can go directly to the NRK's music archive from here and get the full metadata set for this music piece. The journalists and the people working with it can share it directly to the production systems back if they wish. If you play it, you can of course play it directly.
How was it
This kind of visualizations we can use to put on extra information. So here we want to have the pictures of the people talking, we want to have an identification of it's music or not. Probably also the rights. Do we have the right to reuse this part or not? You know, like with colors or something. So this will be, much more information will be put onto this, this stuff here. So, and this is the same kind of data as the same kind of solution that we use for the folk music archive. So it will look exactly the same, or not exactly the same, but very similar. Let me say it like that. So you recognize here that we have a similar playing lists, and we have similar layout here on the metadata and everything. So. And all this information is also available in machine-readable format. So from here you can get this RDF graph if you wish, or you can get JSON to put in a search index. So there's a lot of possibilities with this this solution for cooperation and for testing. And yeah, so this is a good starting point for cooperation.
Yeah, looks great. Questions, comments?
Thank you. I wonder, when you have this voice recognition and identification of this huge big data, will you possibly run into privacy protection problems in the sense that now suddenly we have fingerprinting of the voice of very many people that could be used for quite other than journalistic purposes?
Yeah, I mean, that's a very good question. We just had this example today when we were thinking of throwing all this out to the general public. And then there was a very good example that I wasn't aware of. Lars Lilo Steenbeck, He is not very fond of say or her, but he talks with NRK. So if we have an interview with him, it goes on the radio, it goes into the archive, and it goes on the net straightly afterwards. Say or her just captures that like 20 minutes later and starts to publish it on their own web pages. He will probably not talk with NRK anymore because we then published his thing. You know, like that kind of rights. This is a simple example. It doesn't hurt really somebody, but there are more severe cases as well. So where do you go? How far can you go? We don't know. I mean, we are looking into GDPR, like everybody at the moment. We are looking into this. I mean, Google doesn't care much. Facebook doesn't really care. They just do at the moment. We want to be straight with people. We want to do this correct, but there is no real correct way to do it yet because this kind of technology is not yet accepted by politicians. I mean, they don't really look into this yet. So this is really a difficult area at the moment. I completely agree. We don't really make voice prints yet, but we are trying to interpret voices of the same person over time. So, yeah, it might end up with a voice print. And is that okay or not? We don't know. Do you have an answer? It's quite difficult, yeah. But it's the same for iPhone. iPhone is now scanning your face with 30,000 points. So Apple knows what your face looks like better than the American Immigration Office. Is that okay? I mean, there is quite some ethical questions at the moment. But these people that are in our archive are people in the public room, in the offentliche room. So that they have been published, they have been on broadcast, they have been on radio. So the law is a bit more flexible with them. I mean, Jens Stoltenberg is not that unknown. But sometimes you don't want to have this kind of... We have examples of young children interviewed in a school, at a school place, you know, like just on the local radio. Do you want to have them voice printed? And maybe not. I mean, so, yeah. We have some things to think about. Definitely.
I have a question about the collaboration between you and the National Library and this situation with these two archives, huge archives. What's the situation there, and what's the future of these archives working together?
It's a very bright future. No, I'm just kidding. Now what we're looking into now, you want to say something? Yeah, we just want to say that we want to have the same software infrastructure for this radio archive at the National Library and NRK, so that we have exactly similar solution. Maybe it's one solution that is available in both places, or it's two solutions talking together. We're working with that now, but it will be exactly the same in-hall content at the National Library as in NRK. Yeah.
Yeah, that's the whole point, and it's also based on open software solutions and so on. So we are considering offering it as a solution to other folk music archives in the future too, because they have the same need when it comes to getting new systems for the old solutions that like Fiol and other systems are using, and they're blueprinted by the developers working together with the folk music archivists. So it will have all functionalities that the old system has, but all the advantages of the semantic web solutions. So our first goal is to establish a joint system together, and at the National Library we're also very into having a solution for long-time digital preservation that can communicate with this system, because we have our obligations there. So that's a starting point, but I think it's interesting to have this dialogue today to look at possible future collaborations also when it comes to the research projects and other things that we are involved in too, because we have overlapping interests here in different ways. I think some of the challenges might be when it comes to giving access, when it comes to rights and rights management and stuff like that. Yep. Because the sound files that are used for the SoundTracer project so far is sound files that are that don't have any copyright issue, because they're old and they're based on traditional material. But a lot of the material in this joint archive will have different form of rights and so on. So we have to look into that if you want to take this up to a big scale. So, but I think there's quite some exciting possibilities there.
But just to make it clear, this archive does not contain material that has restrictions. So this is just like a copy of what has been on broadcast and sound files. So yeah, there are some restrictions, but they're not as severe as this clausuleerd archive. So that's a bit different. So yeah, and what you said is correct. I mean, the software that we develop is based on open source. So there's a lot of community software. We do not have anything that is licensed, so there's no external licenses for this software, so we can duplicate it as many times as we want. It's virtualized, so it's easily scalable. We can use it in different settings. We can scale it up, scale it down. The real problem with these kind of archives is the storage of the video and sound files themselves. Because how many petabyte was it, Geir? 16 or something?
The radio archives now is
Yeah.
The radio archive now is about between 2 and 2.5 petabytes. All the television stuff is, together with production, 30 petabytes plus.
Yeah.
So it's quite a big amount there. But just to add to one of with the rights part here, the most constraints with rights for the radio archive happens to be with music. And it's usually so it has to be in agreement with the rights organizations on the music side. But with radio, it's much less problems, and with television, it's a lot of constraints with rights. So we're working on that. I just also wanted to add on that the digitalization of all the radio archive has been a partly process been between the National Library and NRK. So it's a lot of work that has been done in the last 15 to 20 years up in Mo i Rana. We sent up hundreds and hundreds of tapes every week for digitalization, and we happily to say that most of that digitalization process now is finished.
Yep.
So.
Very good. One final question from me, I guess, here is towards the musical feature extraction. Say that you want to find all the tunes that are in D minor or in triple meter and these type of things, which would necessarily mean that you need to do feature extraction on the audio files themselves. Would there be the possibility of providing access, not for us to download everything so we can do it locally, but support so that it's possible to do some kind of server-based analysis on the material?
Like I said, I mean, it's virtualized, it's Docker containers, so we can just copy one of those. I mean, this is a bit technical, but we can just copy one of those and use that for including a component from you and then run it. I mean, it would be fun to try. Just to complete that, I mean, we are interested in finding out. We got questions from like editorial groups that make radio programs, like we need some music related to summer with a female vocal and only a guitar, and you know, like, so there is actually a need for that kind of feature extraction. Yeah. Yeah.
There's a big difference between giving away, locally giving away song files and giving access to for research. And then there's a lot of less limits, you know. So I agree with Robert.
Yeah. That's good when we agree. Everything is okay.
So then we have a project, a joint project coming up. Well, to kickstart that, I suggest we do have a coffee break now, and we're a little bit ahead of schedule, but that's fine. So I suggest that we do an 8-minute break, and then we start Matthias' lecture a little bit early. If that's okay for Matthias. So Matthias is now he's here from Slovenia, and he will hold the keynote lecture now at the end. But first of all, thanks to Robert.